Welcome. Today is the 18th of February 2022. I'd like to discuss today sheet number 4. Sheet number 4 is very, very important because it contains the foundation, the base, as I call it, of the structure. And it begins to basically take a look at the architectural and engineering aspects of the design of the drawing of the structure, and this is I believe where you begin to look at the very building concepts, the various building concepts that will enable you to build this dome. As you can see, it has a top view or plan view in two directions for reference purposes, and it has two side views. I have lined up the pillars or the columns. These are the main pillars. I have provided lines there for reference, so you know exactly what pillar is being referenced at any one point, any given point. I believe that to be important. And as you can see, there are only two side views. I did not go ahead and, like other sheets, provide four sides, four views. I don't believe that's necessary. Two views from two sides I believe to be plenty enough for construction, for review, for analysis of these plans. So we'll begin taking a look at this aerial view or top view or plan view of the base, what I call the base. Some other people may call it the foundation. And as you can see, there is a grid here of about the dimensions are here provided on this side. 4 foot or 122 centimeters by 4 foot or 122 centimeters squared. So it's a squared grid. And the reason I chose to do that instead of a more fitting polar array of members is for the ease of construction with available materials. Again, I designed this dome to be as accessible for building and construction to the most variety of economies, people, economic levels, to the largest variety of people. Therefore, I attempted to maintain simplicity as much as I could in the areas where I could. So I did that on the inside, beginning with the floor framework. These are 2x6 lumber, or designed to be 2x6 lumber. Of course, there could be other fitting material. And again, as you can see, they overlap into these blocks, this array of blocks, which I discussed earlier. But these are an array of blocks all around the structure, and I'll show you here in this view what they look like from view as viewed from the side. They're laid flat on the top. If we take, let's say, one, and they're laid or erected up. These are two blocks, and this is another block laid flat. If you look at the side, you can see more or less what those would look like when arrayed in that fashion. And of course I detailed what these are: 2x6 lumber wooden grid atop 16 cast concrete feet. I call them cast concrete, but they are actually designed to be blocks arrayed or stacked on top of each other. 8 of them, 4 on top, 4 on the bottom. But they also could be cast concrete. That is a choice. As you can see, these overlap and rest on top of these, and as well as each one of these. These threads rest here. There's a small problem here that I need to fix. This needs to extend all the way up front. I believe it didn't because of perhaps the entrance, but I don't believe that to be necessary right now. I think with the design, the changes I've done, this could rest all the way here, just as these do. And again, you can see the different columns or pillars. These round feet, bases, as I call them, are the concrete footings or feet. These large ones here that go deep into the ground to provide for stability. Again, these provide stability. As you can see, they are buried in the ground entirely, with the exception of the center one, which is this one that goes, I believe there's a mistake here. It should go all the way. Actually, it does show as going all the way to the ground level. No, more than the ground level. It should go all the way up here in line with this. So this is actually a error, drawing error that needs to be corrected. This center pillar that supports this one member, the center one, should be going from this depth all the way to this height, flushed with the these smaller blocks or feet. And again, that's something I will address here shortly. And again, that applies only to this footing, because as you can see, the grid, the 2x6 lumber grid, rests on this as being replaced for one of those. There's not one of those, so this takes the place of one of those. So these are going to be resting on that. So it needs to go all the way up to the level that these are, and all the way down to the level that these are, down on the ground. The very bottom should be at the level that these are. These right here represent the bolts. The I put them as 6 inch, but they're not 6 inch. They are about 6 inch plus 8, which is about 14 inches. So this is another error, another mistake. So these are actually 14-inch anchor bolts cast in concrete. They're not cast. They are inserted in a hole or bore that's provided on the concrete and tightened with a nut and washer, perhaps also a lock washer. I believe there are about 24 of those. And again, what they do is they support they prevent the bottom part of the dome, the bottom belt of the dome from spreading out, which is represented by this yellow belt right here. It's designed to be wooden or made of wood lumber. I believe 6 inch by 1 inch. And these hold it and help it maintain that round or circumference shape. So you can see they are all around. There are about 24 of them, and they again are bored into the concrete. And a better view of that to explain it a little better, they are shown right here from the side. You can see they appear like carriage bolts. They may be just that. And if I dimension them correctly, they are 1 foot 6 inch. So they are 18 inches actually. 1 foot 6 is about 18 inches or 42 centimeters. And in reality, I believe they do have to be about that long or even longer, because there's not only one 6-inch belt from here to here be 6 inch, but there's two stacked on top of each other. So we're looking at 12 inches worth of belt. And I did go over that on the 3D model video that covers this area, this part. So if you haven't already, go ahead and take a look at that so you can see the 3D explanation for that, which may be a bit more informative. But as you can see, there are a few things that need to be corrected on the drawing itself. These again are not 6 inches, they're more like 18 inches. So that needs to be corrected. Again, these are, for the first time, I'm going to be explaining on this drawing these two steel rebar rings, or they could also be steel belts. These two, the blue line shown here just shows the center of this array, but these two red ones represent steel belts or steel reinforcement, which could be rebar, long strands of rebar curved to take that shape and somehow insert it into the blocks and basically filled in with concrete somehow. This could also be a cast structure. This entire array, this circular array, could be a cast concrete structure, in which case it would be a lot easier to insert these two steel belts. And the reason these two steel belts are there is to provide coherence and structural structural strength to this array, because again, as I mentioned before, just mortar and blocks may not be stable enough over long periods. Of course, the ground is slightly moving everywhere. You have to build with that in mind, that the ground moves over time, although it's a very minute movement. But the soil vibrates. The soil, when it comes to temperature, it does breathe. In other words, it expands and contracts with temperature, with humidity. All of that stuff plays a part, and over time these bonds could crack, come apart, and you can have blocks coming loose if it's not for these steel belts or steel rebar or reinforced bars. So that could be a challenge, putting those bars into the blocks and then filling them in. Or it could be something that a method could be developed to where it could be an easy thing to do. These also, the red lines here, dashed lines, are rebar reinforcement for this concrete pad. This is a concrete pad ramp as detailed here. And I should show those here as well. That is something that is missing in the drawing. This is the pad right here. And in the center of that should be a line that represents that grid, that steel rebar grid. Should be shown right there. And again, that's for structural integrity. You're going to be walking up and down, perhaps rolling some heavy furniture, equipment up and down this. So you don't want it to just be concrete. You want it to be reinforced. As you can see, it does have a wedge here that supports it. This is presumably also concrete filled in. But I believe if you reinforce it, even with thinner or smaller gauge diameter rebar, it would be very advantageous to do so. As you can see, the view here shows this is filled in. This is what is shown in these views, mainly the base, the foundation. And I did include these columns in these foundation drawings because they are cast in concrete. These columns, or pillars as I call them, they are all cast in concrete. And these round cylindrical concrete bases or feet. These right here. Not these. These are the block footings. The eight block footings. These are the larger cylindrical feet that where the pillars are encased in, and these are most likely to be cast concrete or poured concrete, poured into some kind of mold shape cylinder with the pillar or column already in it, perhaps with some sort of hooks or like a piece of cross wood or a piece of wood that's crossed into the pillar on the bottom where it's cast in concrete for stability, so it doesn't just come loose and could be easily pulled out. Although gravity will hold it in place, I believe nothing's gonna just pull it off straight up. It would have to be straight up if it didn't have some sort of hook or cross member here, like bolts or pieces of steel, pieces of shafts of steel shafts or steel cylinders crossed across these embedded parts of the column right here. It could be not too many, maybe like 3 crossed in different directions. Again, to provide a grip so they can grab onto the concrete and not allow these to rotate or be pulled out, which again is very unlikely, but I believe that adds to the stability, to the integrity, structural integrity of each pillar, and in exchange for the entire structure. This right here is a representation of the copper lightning arrestor. This is the tallest, highest point of the structure, and I believe a lightning arrestor is something necessary there. So that's represented there. Of course, it would be electrically bonded all the way to the ground, or grounded, electrically grounded, and going into the ground, perhaps to another electrode or copper shaft, steel shaft that goes deep into the ground, at least 10-12 feet. This is the ramp, the side view of the ramp again. As you can tell, this wedge piece here is presumably solid concrete, and as you can see, it's buried in the ground a few inches at least, perhaps 8 to 12 inches. And as you can see, even this part here is partly buried here towards the end, so this could be flushed with the ground. This represents the ground level. And as you can see, the ramp ends at ground level right there. So from this point down, it's buried. So you can see quite a bit of it is buried into the ground. I believe I may have provided dimensions for that. Maybe on this side. I provided dimensions for the structure, but not for the depth at which it is buried. Maybe I should provide that in a later version of this. I provide the angle at which this is built, 14 degrees. The length of that rail, which is presumably the same length almost of the ramp itself. I also provide the dimension for each one of the pillars or the columns. Again, these seem to be divided right here, but that only shows the level, the floor level, more or less. These have been changed, updated since this drawing was made. So they should all be at the same level. And they all they do is show where the ceiling line for the first deck is. They don't show where they should be cut or anything like that. These are whole members, should be whole members, to provide the greatest integrity, structural integrity for the dome. And as you can see, the tallest of them is about 945 centimeters, 31 feet. And they go down from there. Various dimensions for various different parts. I would focus on the centimeters part of the measurements, because I believe the minimum measurement for the as set up in the dimensions is 6 inches, but this could be less than 6 inches, as this one is. It shows 0, but in reality is more than 0, of course, since we have 4 centimeters. It's perhaps 2 inches or so, or 1 inch, less than 2 inches. And again, this is the line of the second level. I'll call it deck. First level is from this line and up. And in reality, it's more from this line right here that needs to be adjusted, changed. It's actually from this. This is more like the floor level right here, right in between those two 6-inch belts. This line right here is more, it more actually represents the floor level. And again, these columns are whole members from base to top. And that pretty much wraps it up. That pretty much explains most of the aspects of the base plan, which again is also known as the foundation plan. This is designed to be built on packed ground, not necessarily anything else like concrete or anything. This could be built right on the ground as long as it's packed packed. This represents packed ground, compressed ground. You want it to be uh, quite dense, so it can provide the most amount of friction, therefore stability, vertical and horizontal stability for all the members, especially these concrete footings, which provide a lot of the inside support for the inside structure. Again, that's sheet number 4, or the base plan, or the foundation plan. Thank you very much for watching.